Welcome to our next session of the Technomatics Virtual User Group, our community conversations for our virtual user group here. Thank you. It's Siemens Software. My name is Taryn Blake. I'm the Community Engagement Program Manager for the Siemens Software community. And we are here with another tutorial session. Today's topic is dynamic model creation. And our usual host is back, Mr. Stefan Bongso. He has been a freelance simulation expert for a very long time, for several decades now. He's completed hundreds of projects and training sessions, and he has 5 published books on plant simulation, and he's working on a 6th book and is one of our leading contributors to the Siemens PLM community. So the big steps for our agenda today, 3 big steps, are creating a data source, object creation and positioning, and then connections of the objects themselves. So as always, we are completely live today. Stefan will be doing the tutorial live as well, and then we will conclude with a live Q&A. So you can raise your hand using the raise button, should be in the middle upper menu on your screen, to ask a question verbally. And then of course we do have the chat available for questions as well. So that's the end of my intro. Stefan, feel free to take the screen.
Hello again for our next webinar. Today I want to create together with you a model dynamically, and we start with a data source of what kind of data we need if we want to create a model complete on the fly. And so first I include here a data table, and I name it data. And these data can be, you can import this data, for instance, from Excel or from a database where you edit this data. And maybe you have a web application where you create the data and edit this. So I will create this data here in a plan simulation. I want to have the column index, and we need at least we need names for the parts, for the stations, and we need one object type. If we want to create something, we need to know, okay, what is the class from the class library I need to use to create this object. And so we need to define this object, for instance, as source or as stations. For connections, we need successors. And we need, for 3D, we need a position, X and Y. I format this as a real data type. So we need an X position and a Y position if you want to have some visual representation of your model. And we need a lot of attributes for the objects. At least we need, for instance, the processing time. Maybe also some failure times, failure data, availabilities, the mean failure duration, and so on. So it can be a lot of different attributes here. Okay. But this is, I guess, really the absolute minimum we need. Names, I want to create 4 machines, a source and a train. Very simple. machine 1, and train. And we need to define a source type, and the class for the source is source. Machine could be can be a station or a parallel station. So I take the station class from Blend Simulation as base here. And train base for the train is the train from the class library. So it's quite easy. Successors. Source should have 2 and 3 as successor. It's the line 2 and 3 from the source. It goes to machine 1 and machine 2 in parallel. And I use here a string with a separator. It's the comma as separator. And 2 times 4 from machine 1 and machine 2. The successor is machine 3. And after machine 3 comes machine 4. So we have the successor 5. And the machine 4 has as successor the number 06. It's the train. You can also use predecessors here, and you would have some different numbers then. And I take this field as string, so I can place here more than one value here. This is quite common in databases that you have collections as comma separated variables as CSV, for instance, and we need to split up this in Blend Simulation later on. Okay, positions. Here in 3D, it's meters or feet, depend on your basic settings in Blend Simulation. 10, 10, 10, 20, 20, 15, 15, 15 for stop. This was the Y settings. 10, 20, 20, 30, 40, and 50. This step you don't need if you don't want to have a visual representation of the model. If you have only the model in the background, for instance, on a web service, so you don't need to show anybody the model, and so you don't need the position. Processing times 120, 240, 240, 120, all in seconds. I guess you know that Blend Simulation, the time data type is based on seconds, and you need to be really carefully if you use databases and use some internal database time formats. So you need to inform what is the base for this time. And so it's easier to have, for the first step, a real value in seconds, and then you can create from this value the time data type in Blend Simulation quite easily. Okay, now I have the basic information for my creation process. So again, we need a name with all the rules we have in Blend Simulation. Then we have object types. This should match the object types in the class library. We have successors or predecessors. It's on your to find a way how it looks, how it works better for you. We need positions here in meters in plan simulation, and we need processing times and a lot of other times that you want to have as attributes behind all the objects. Okay, and with this data, we can go into the creation process. And for creation, we need a method. I name it create objects. First, we need some variables. I want to have for better reading object and object class. As object, I want to run loops here in this in my program, and so I need some iterators for the loops. I have 2 here. I have some coordinates as real or length. And for my successor lists, I need an array of type string. Okay. Basically, I run through my data table here and create step by step, line by line, the objects. In the first step, in the second step, I need to connect the objects in the right way. So I have 2 steps. First step is create all the objects. If I want to create an object, I need first a link to the right class in the class library. So the first step I need to do here is to create a link to the class in the class library, and we have the information for this in the second column of this this table here, and we need to create from the string source, for instance, we need to create a link to the right class here in the class library, and here we have at least 2 different ways we can do this. One way is to use the conversion method str to object. Here I can create dynamically one path to this object by connecting a string with my data here, and this is resulting one path, and with str2object we can create from this path an object. Another way could be to use the method extend path. Extend path starts with a folder in your class library, and then you can add a string to complete the path, and this method will return an object data type. And so there are different ways to do this. Then we need then I need the coordinates x, y. It's just to get a better readable code here. We find x in data in the fourth column of data, and the y coordinate we find in data in the fifth column. And the name is already string, so I can use the name of the objects directly, and so I can create the object. Yeah, in 3D, you need to use derive here. The first step is you derive from a class. An object, and you can hand over the name, and the name we find. We need to define the destination. We create this object in root. Otherwise, if you can also use derive to create another class in the class library, and if we specify a frame, then we will create this object in a frame, and then it's really an object, not a class. And as a second parameter, I can define the name, data, and derive will return here a link to the object I create, and using this link I can set, for instance, attributes, and I can set here in this case also the positions of these objects. So in the next step, I want to place the objects. We can have a look here in this already to see, okay, if we just call derive, where in the frame Blend Simulation will create these objects. I save my changes here and call the method here, and you see, okay, it's the position 0, 0 here in this frame, and all objects will be created here at this position. I delete all these objects, and you see all at the same position. And so we need to position these objects, to place them in the frame, and to change something here in 3D, we need to call a 3D method with underline 3D. You can use position if you have to position your objects, and position wants to have an array with 3 values, x, y, z. X and y we have, and z is 0 in our case. And then we can have a look, and then it distributes the objects in the layout with the data we have used here. And now you can see here are the objects. One is missing. Okay, I guess my data are not right here. So I checked the data. Okay, I have here the same positions for 2 objects. And I need to correct the data here. And 2020. Okay, this needs to be 10. Okay, one thing we have to remind now already, if you start now the second one, our method, then we get an error message. This is because of the data. If we set fixed names, then we cannot start this this method twice, because the names machine 1, machine 2 are already set in this frame, and we get an error message: invalid identifier, or identifier already exists in name scope of the objects or one of its instances. So before we start this method, we need, as a first step, to delete all old stations here in this frame, and this we make later. So I delete all the objects manually, and then I can continue with my method. Okay. The next step, next step would be to set the attributes for the objects. And here we have a little problem. We have a source, and the source don't know the attribute proc time. We need to set the time for the source with interval. And so we cannot use the same code for all objects. And so we need to differ between objects. And we can differ it with the class names here. In this case, only the source needs to have here another code, because this is not proc time here, it's SymTalk interval. And so if the object type is source, then I need another code. And so I need a branch here. This is one way to do this. I can also compare the class directly. And if this is a source, then I need to set object interval. And I need to change the data type with num time, and I find the data in my column 6. For all other objects I have here, I use, instead of interval, proc time. And this we can check again. So I have here my objects. I set here my processing times. And I have the interval for the source here, 2 minutes. Or the same like in my table here. So this is working. And the next step would be to connect all this stuff together with connectors. And this is quite easy. We need the class connector from the class library, and the class collector offers a method with the name connect. And we need to set the two objects we want to connect with a connector. But first, I need to split my connector column, my data from the connector column. Some elements may not have a predecessor, like the source. The source don't have a predecessor, or sources don't have predecessors, and so I need to check if we have some data in the third column. And then I need to split this. And there's a method for this in Plan Simulation. It's split string. We need to hand over the data, the string. This is the value from the third column in my table. And I need a column, the delimiter here, it's a comma. In our case, you can use other delimiters. And then I need to connect so this is successor list is here a string of array of strings, and so I need to change the data type here to integer, and I use a second loop here for k is 1. So the objects I find in the list in the first column, I have all the object names, and the connectors I create with a method from the connector class. And so I can track the connector class here into my plan simulation and my SimTalk editor, and then it comes the right path, material flow connector, and the method is connect. So connect. So, and this is a little bit more complicated here. Make this the first object I need str. The first object is the object from the first column here. And then I need to connect with the object that is resulting from the row number from the successor list here. And so it's the same first str object. And then I need to
Stefan, there's some folks in the comments who are concerned that there might be a typo. Oh, if. They said if data, 3.1, I think. Let's see.
It should be an E again.
There, okay, okay.
Yes, there should be an E here. It's right. Maybe this column is empty completely, and then we don't need to create any successors. And if this field is not empty, then I split this data. Okay, then that should be 4 here. And then connect. Then there are 2. Yes, there's another split string to num here, and then you can create directly a number, an array from data type integer from this, and then it becomes easier to read. Okay, let's try this. So again, I need to delete all this stuff here. Interesting. Okay, I need to check this here. Should work. Oh, there's a failure here. It's only a sublist dim, not ydim. It's an array, not a table. Yeah. And now it connects. My objects. Okay. Here, this is dim, not ydim. Sorry, but it's live. Okay, now we have one problem. We need to delete all this stuff again here, so we don't get a failure. And so I want to have a method to delete all the objects I create dynamically. And so I make a second method. To delete all the objects. Not all the objects. We need here our event controller and the data I want to keep here, and all my methods I want to keep. And so I only want to delete stuff, the classes from source and station and drain. And I need to run through the complete frame and decide, okay, this I want to keep, this I want not to keep, and then I want to delete this. And if you want to do such things, then you have or the frame itself provides methods for this. And the first method is num roots, num nodes. Nodes are all in your frame, and the nodes has some index. Every node has an index, and the index depends on the order of the creation of the objects. And so I start from behind, from num nodes down to 1. Because if you delete one object, then the node number changes. And then I need to check if root node y. This is the way I can access each object in my frame with node and then an index. And I can, for instance, check the class name. And the class name should not be method. And I want to keep the data tables. And the event controller I want to keep here. All other objects I want to delete. And I delete objects with delete object. There are several different ways how you can check the object types class is one, but if you get into the attributes and methods of the station, then there's a resource type attribute or internal class type. A resource type I want to have. Resource type, and there are four different types of resource types in plant simulation. It's production, store, transportation, and information. And so you can make a wider definition what you want to keep and what you want to delete. And it's also better to use resource type if you have a lot of custom classes with a lot of different names. And so you can say, okay, all resource types production I want to delete, for instance, or all transports or storage. And so each of the material flow elements has this attribute. For instance, if you have a buffer F8, then this is resource type. Storage. And so we can say, okay, it's storage, transport, and production. We delete all this, and all the other objects keep in this frame. Okay, let's have a check here. I run this method, and all this all the objects are deleted. And now I call at the start of this method, I call delete objects. Wait. Okay. And then you should be able to run this method several times without any error messages. Okay, that's it. It's only this was only the easy part. Much more complex is if you have transport stuff here, if you want to create conveyors or tracks and so on. And this is a little bit more complicated. But the basic approach with this 3 steps is still the same. You have to derive the class. You have to position and connect all this stuff together. If you have length-oriented objects in plant simulation, then you need to create the curves here, the curve segments of these objects also dynamically, and this is a little bit more complicated. Okay. Any questions here?
Yeah, feel free to use the raise button to raise your hand. We can take you off mute, or you can also type a question in the chat. There was a lot of conversation about the code, but it looks like folks have kind of answered themselves there in the chat. And if people are still thinking about questions, I'll take this moment to steal the screen just to show what the next sessions are. So you still have plenty of time to ask a question. I just want to bring everybody's attention to the slide on the screen, which shows the link, which you can click on it, to the forums for the Plant Simulation Virtual User Group. that is where we post the recording after the sessions. So the recordings are all there. And then we also post when the next session is available for registration, we put that in this at that URL as well. And then you do see on the screen, it's a screenshot of the page with an animation showing you how to subscribe to the topic by clicking the follow button and then clicking the envelope icon and choosing every post, which will make sure that you get emailed for each of the messages that we post about recordings and about new live sessions. So our next two topics that Stefan will be hosting are April 9th, accessing plant simulation in web applications using Python, and on April 8th, or April 23rd, how to create a lift based on a conveyor. So that is it for the kind of the housekeeping things here. And if I'm not mistaken, we did have a question pop up in the chat, but it looks like it disappeared. So if you do have a question, feel free to raise your hand or type in the chat. Similarly, the screen that you're seeing right now is a link to Stefan's customer community profile. So that's how you can get access to his contact information there in the community. You can click on that. And once again, the other link is to the forums for the Technomatics Plant Simulation Virtual User Group area. You can always ask questions on the videos later. Once the video is posted, you have questions still, you can @mention Stefan and continue the conversation in the forums. So it does look like Luis has a question there in the comments, and he would like to ask, why use num to time for processing the time? Because he felt that directly putting the real value works as well. So maybe Stefan, if you want to show the code again, you can explain why you preferred that choice.
If you work with different versions of plant simulation, then you maybe get some error messages if you use real for time. I guess in the newer versions, it only comes if you have some times some values with for speed, for instance, it doesn't work. I make it as principle here, so I get the right data time. But yes, if you have already real, then it's good. But if you import data, you have string, and then you need to convert it into the right data type. Yes, and now you can also use it directly. Again, one remark from my side: if you have any topics you want to see in such format, half an hour, 45 minutes, then please post it. You can do it in the community or here in the chat, or write an email to me. We are looking for new contents to continue this this webinar series for a very long time.
You got some hand claps there, so that's good. Always good to hear that this is useful for the audience, for everyone. So if everyone's going to be silent, it looks like we might be ending a few minutes early today. I'm surprised. But yeah, another thank you. Definitely thank you, Stefan. We appreciate you doing this, taking your time.
Thank you.
But if
Maybe
that's all,
until next time.
Yeah, see you in the forums.
Goodbye.